All right. On number 1, what reason could we give? What reason could we give that these two triangles are congruent? I'm sorry, I thought I heard somebody say something, but I couldn't make it out. SAS, side, angle, side. We have a side that is marked as 7 on both of these triangles, so there's my side. We have a side that's marked on 8, marked as 8 on both of these triangles, so that's another side. To use side, angle, side, I then need the angle in between those two sides, the included angle, and that's my 60-degree angle right here. It is sandwiched in between those two congruent sides. What about on number 2? What's the reason that we could use there? Angle, side, angle. We have 2 marked angles and the side in between. On the other triangle, we have corresponding marked angles and the side in between. Number 3, what can I use here? None. I have a corresponding side right here, AB and ED. I have corresponding sides BC and CE. Do we know about side AC and CD? Those do not have congruence marks on them, so I don't know anything about them. I do have my vertical angles right here, but if I mark those vertical angles, what I have is side, side, angle, which is not one of my congruence criteria. Side, side, angle does not work. And the very last one, number 4, what could we use here? SAS, we can use side, angle, side. We have these 2 corresponding sides marked, AB and BC. We have this angle right here, ABD. That would be congruent to the other side, which would also have to be a right angle. So I have corresponding right angles. And then we have our shared side, DB, that is congruent to itself on both of those triangles. So I have side, angle, side there. All right, please go ahead and pull out your notes. We had 2 more proofs to finish on the front side of the 4th piece of paper. So again, next to last page, we had 2 proofs to finish up here. What should my first statement be? What should the first statement be that we are going to make? TB is the, and then what does this symbol mean, this upside down capital T? What does this symbol right here mean? Perpendicular. TB is the perpendicular bisector of RS. All right, before I worry about what that given information can let me do, is there anything that I'm allowed to mark on this picture without being given? I can't mark my right angle, but I will get that because I'll use my given information to get there. My reflexive property. We have this side that is shared between the 2 triangles completely, and so it is congruent to itself. Yep, come on in. So we have segment TB is congruent to segment TB. Anytime I have a shared side between the 2 triangles, every piece of it is the same between those 2 triangles. It is congruent to itself using the reflexive property. Right. Now, Levi, we're going to be able to mark some right angles, but I have to use that given information to do it. Which word is tipping me off to the fact that we're going to have right angles? Perpendicular. They used a symbol for this, but we know that word is perpendicular. So TB right here is the perpendicular bisector of RS. So where are my right angles at? B on either side. How big are right angles? 90 degrees. I can't just call this angle B because I've got two angles that have B as the vertex. So I have to give them three-letter names. The measurement of angle RBT, B has to be in the middle because it's my vertex, is 90 degrees because it's a right angle. And the measurement of angle SBT is also 90 degrees. What was the word that told us that again? Perpendicular. So we are using the definition of a perpendicular bisector. Well, if those two angles are both 90 degrees, then what do I know about them? Yes, Keisha, you had a question? So what we're using to say this right here is this piece. We're using the perpendicular piece to say that they're both 90. But you're right, we can say that they are equal to each other. I can say that the measurement of angle RBT is equal to the measurement of angle SBT. I can't use the bisector part because my bisector is telling me about cutting an angle, and I have this side over here. So I'm taking the side and cutting it in half, and we're going to use that piece, that bisector word here in just a moment. If I know they're both 90, why can I say that they have to be equal to each other then? What'd you say? They are the same, so how do I know? Like, what am I using to say that they're the same as each other? Because I know that the first one is equal to 90. I know that the second one is also equal to 90. What did you want to say? I know the first angle is equal to 90. I know the second angle is equal to 90. So why are they equal to each other? Not because they share a side. I don't know that the triangles are congruent yet. All I know right now is that both of these angles are 90 degrees. If they're both 90 degrees, then why do they have to be the same size as each other? Super close. We're going to use that in just 1 second. This is, we could either say substitution, or we could use our transitive property. If I'm using substitution, what I'm saying is I'm going to take this 90 right here and replace it with SBT. And I can do that because it has an equal size to it. I'm taking one thing out and replacing it with something else of equal value. That is my substitution. Transitive property says if I have one thing that's equal to a second thing, and that second thing is equal to a third thing, then the first and the third have to be the same size. That's my transitive property. Leo, we're going to use definition of congruent angles here, because if I know their measurements are the same, then I know that those angles have to be congruent. I said their measurements are equal. Now I'm saying they're congruent, which I have to say they're congruent if I'm going to use a triangle congruence criteria. This is our definition of congruent angles. Has so many words to say that those two angles are the same size as each other. All right, so now I want to use the bisector word here. What do bisectors do? They cut things in half. So this line, TB, or line segment, so right down here at B, is cutting RS in half. If RS is being cut in half, what can I say about those two smaller sides now? They're equal to each other. They're congruent to each other. So RB is congruent to SB. What word told us that? Bisector. So once again, I'm using the definition of a perpendicular bisector. I can't just say definition of bisector because they told me it was a perpendicular bisector. So this is the understanding that I'm using. Look at the way our triangles are marked up. Do I have enough information to say these two triangles are congruent to each other? Yes. Using which congruence criteria? Side, angle, side. So we're going one line below what it says here. So triangle RBT is congruent to triangle SBT by side, angle, side. Let's look at number 6. What should the first statement be on number 6? The given information. So AC is parallel to BD. I'm going to go and mark that on my picture. AC is parallel to BD. That's not the same thing as congruent, so I'm not putting congruence marks on it. They're parallel, so I'm putting little arrows on them. And CD is parallel to AB. So the top, I'm going to put 2 little arrows on it because it's not parallel to my sides, my left and right. CD is parallel to AB. Is there anything in this picture that I'm allowed to mark without being told? Would you say AD is AD? AD is congruent to AD. That's that shared side right here. What reason can I use to say a shared side is congruent to itself? Reflexive property. All right, now I have to use that given information. When they give me information about parallel, what kind of shape do I want to try to draw? A Z. And when I draw that Z shape, what am I looking for? What kind of angles am I looking for? Alternate interior. So I'm going to go across AC and BD, my left and right. Is there any way I could connect those two to make a Z-type shape? DA right here, that shared side. I almost always use colored pencils when I'm doing this myself on my own work, because if I use a colored pencil to make that Z shape, I need to connect the color to itself. So like I can't go up here, this is not my angle, because that's connecting orange to nothing, no color. I also can't do this angle right here, because again, that's orange to no color. I need to connect orange to orange here, and orange to orange here. Can I call this one on the bottom angle A? No, there's 3 angles there with A as the vertex. I have to use a 3-letter name there so that I'm very clear. What could we call this angle at? What'd you say? CAD. Angle CAD is congruent to, what can I call the angle that it's congruent to? BDA. Angle BDA. Remember, my vertex, A and D, has to be right in the center. What kind of angles did we call those again? Alternate interior. So we are using our alternate interior angles theorem here. So that uses this piece of given information. I also have information about two other lines being parallel. They told me that CD, the top, is parallel to AB, the bottom. Could I connect the top and the bottom to make a Z shape? By going over what? DA again, using that shared side again. And then my corresponding congruent angles are going to be my alternate interior angles. I can't go over here because that's connecting orange and blue together. It has to connect blue to blue. So this angle right here, that's blue to blue. And this angle down here connects blue to blue. What could I call this angle up on the top? CDA, angle CDA is congruent to, what can I call this angle down here on the bottom? I could call it DAB or BDA. Sorry, BAD. BAD or DAB. I feel like I switched my letters around when I was speaking and I apologize. DAB or BAD. What's my reason for being able to say that? Alternate interior angles theorem again. Whenever they tell me about parallel lines, I'm going to find alternate interior angles. Look at the way we have these two triangles marked up. Do I have enough information to say that triangle ABD is congruent to triangle DCA? Yes, using which triangle congruence criteria? Angle, side, angle. Triangle ABD is congruent to triangle DCA. We're going to skip the back side of this page, so go to the front of the last piece of paper now. Front of the last piece of paper. It's been a minute, but we did talk about what CPCTC means. CPCTC means corresponding parts. That's that first C and P. Corresponding parts of congruent triangles that's the next CT. So we have CP, CT. Corresponding parts of congruent triangles are congruent. And we've used CPCTC already. When I gave you a triangle congruence statement, we were able to use that triangle congruence statement to match up the parts that were corresponding and therefore had to be congruent to each other. You can only use CPCTC after you prove the two triangles are congruent. If you don't know those triangles are congruent, then you cannot talk about any parts except what was given to you or things you're allowed to mark without it being given. So to give you an idea of how we're going to use this and what we're going to say, that proof that we just did a moment ago, this one right here where we ended by saying these two triangles are congruent, using CPCTC, I would now be able to come in and say that angle C up here is the same size as angle B. Because when I look at my triangle congruence statement, B and C are corresponding parts in those triangle congruence statements. And so I know that they are congruent to each other. I wasn't given that information. I couldn't figure it out from parallel lines. It wasn't something I was allowed to mark without being told. Once I know the triangles are congruent, then I can go on and match up all the other corresponding parts and say they would have to be congruent to each other. Yes. So what we're going to do for the rest of our time together now is proofs that look exactly like what we've been doing, except we're going to take them one step further. We're still going to show these two triangles are congruent to each other using one of our 5 methods. And then we're going to take it one step beyond and say that means these parts have to be congruent to each other. All right, so I want to look right below where it says CPCTC at this picture here. Proof number 2. My given information is that angle E is congruent to angle M, and O is the midpoint of GT. Well, that's what they wrote right here in my first statement box. So my first reason back here would be what? Given. The next statement that they made was that segment GO is congruent to segment TO. Here's GT, and here's point O. What were we told about point O? It's the midpoint of GT. So why could I say that GO is congruent to TO then? Definition of midpoint. We are using the definition of what it means for something to be a midpoint. Next statement they made for us is that angle EOG, what's the vertex of angle EOG? O. So EOG, E to O, then up to G. So this angle right here, angle EOG, is congruent to angle MOT. MO and then down to T. This angle over here. Why would we be allowed to say that? Vertical angles theorem. Do I have enough marked up on my picture to say these two triangles are congruent? How many corresponding parts do I have that are congruent to each other marked right now? I just have 2. Did I use all my given information to mark up my picture? Did I mark this on my picture? No. Let's go mark that. Angle E, this guy over here, is congruent to angle M. That was part of my given information right here. They look like right angles, but I don't know they're right angles, so I can't put the little box on it. I can mark them as being the same size as each other. Do I have enough information now to say that these two triangles are congruent to each other? Yes, I have 3 pairs of corresponding congruent parts. What reason could I use to say these 2 triangles are congruent? I can use side, angle, angle. Or you could write that as angle, angle, side. The important thing is that the side is not in between those 2 angles, because when I look at my picture, the side that I have marked is not the one that's between those 2 angles. So I can't say that in my statement. All right, let's name these 2 triangles. Let's write our triangle congruence statement. They didn't give it to me this time. Let's call the first one triangle GEO. If I name that first triangle GEO, how does the second triangle have to be named? I heard T, and then what was the next letter? TMO. G and T are corresponding, E and M are corresponding, and then O and O, those are my vertical angles, so those are corresponding. What did they want me to prove in this? That G is congruent to T. So my last statement, angle G is congruent to angle T. Do we already know that these 2 triangles are congruent to each other now? Yep, we just did that in the step above. Are angle G and angle T corresponding parts? Do they fall in the same place in my triangle congruence statement? Yep, first letter, first letter. So those corresponding parts of my 2 congruent triangles have to be congruent. CP, corresponding parts, CT, congruent triangles, are congruent, C. I'm only allowed to use this after I make a triangle congruence statement. If I don't already say that the triangles are congruent, I cannot use CPCTC. We have to have that first. All right, let's look at number 3. What should I put as my given information? We have that BD is perpendicular to AC, and what else? And AB is congruent to CB. My reason for that would be because it is given. And then I'm going to put a big line here to show that I am done with that step. Do we have this congruence marked on our picture? AB is congruent to CB. If it's not marked on the picture, we should add it. AB is congruent to CB. Is there anything on this picture that I'm allowed to mark without being told? BD is congruent to BD, absolutely. BD is congruent to BD. What reason can I give for that? Reflexive property. All right, so that's my second step. Draw a line. What does it mean for 2 things to be perpendicular? They form right angles, and right angles are how big? 90 degrees. So BD, this shared side, is perpendicular to AC, the bottom. So we are making right angles here, and right angles are always 90 degrees. So angle ADB is 90 degrees. And angle CDB is also 90 degrees. And how did we know that? What was the word? Perpendicular. We are using the definition of perpendicular line segments. Because they told me up here that these line segments were perpendicular. If I know that both of those line segments are 90 degrees, then what do I know about those two angles? They are congruent. The measurement, so I forgot my M's here, the measurement of angle ADB is equal to the measurement of angle CDB. Why can I say that? Substitution. Or we could use what here? If we didn't want to use substitution, we could use transitive property. If the measurements of those angles are equal, then what else do we know about them? What has to be true about those two angles if they have the same measurement? They are congruent. Angle ADB is congruent to angle CDB using the definition of congruent angles. That's a whole lot of words to say that my two angles are congruent to each other. Not just that they're congruent to each other, they are 90 degrees, right? Can I show that these two triangles are congruent to each other now? Do we have enough mark to say that these two triangles are congruent to each other? Yes. Using which congruence criteria? Side-side angle. Can I use side-side angle? Side angle side, that's if I have the angle that's in between those two sides. So that's if I had this angle up here. What kind of triangles are these again? We can use hypotenuse leg here. We have right triangles right here. This side over here is the hypotenuse. So we can use hypotenuse leg to say that triangle, I'm going to name the first triangle ADB. What would the name of the second triangle have to be if I call the first one ADB? CDB. Triangle ADB is congruent to triangle CDB using hypotenuse leg. What were we supposed to show in this? AD is congruent to DC. AD is congruent to DC. Well, that's the first two letters here and the first two letters here, which means those two line segments are corresponding. Do we already know the triangles are congruent? Yes. Then what reason can I use to say that these corresponding parts have to be congruent? CPCTC. Nice work. Let's flip this over on the back. First statement should be what? NO is congruent to MP. Anything else? And NO is parallel to MP. My reason for all of that? Given. Do I have that congruence, NO and MP, already marked on my picture? Nope, let's go add it. It has a parallel mark. We're going to add a congruence mark. So NO is parallel to and congruent to MP. Is there anything on the picture I'm allowed to mark without being told? MO. MO is congruent to MO. My reason? Reflexive property. Let's go mark that on the picture. Shared side is congruent to itself. They told me about parallel lines. What shape do I want to make when they tell me about parallel lines? A Z. So I'm going to go on top of my parallel line NO, on top of my parallel line MP. Can I connect those in a Z shape? By tracing over what else? MO. What kind of angles do I find when I do this Z shape? Alternate interior angles. Angle NOM, this one right up here, is congruent to angle what? PMO. PMO. This one right here, connect orange to orange. My reason? Yep. Alternate interior angles theorem. Do I have enough marked up on these two triangles to say that the triangles have to be congruent to each other? Yes, using which congruence criteria? Side angle side. The angle that I have is smashed in between those two sides. So I can say triangle, let's call the first one triangle NOM, N-O-M, is congruent to, now we have to match up our corresponding congruent parts. What should the second triangle be named? P, M, O. Triangle P, M, O. What do we know about angles N and P because of the way we wrote that triangle congruence statement? Yeah, CPCTC, those are corresponding parts. So I know that those two angles have to be congruent by CPCTC. All right, let's do one last proof, and that will finish out our notes. Number 5. What should I put in that first statement box? It already tells me my reason is given. AB is congruent to BC, so I'm going to mark that on my picture. AB congruent to BC. Anything else? And D is the midpoint of AC. They tell me my next reason is isosceles triangle theorem. I normally like to use reflexive property next on this one, but they already gave me my next reason. Does anybody remember what the isosceles triangle theorem says? Yes. If two sides are congruent, then the angles opposite those sides are congruent. So what are the angles opposite my congruent sides? A and C, C and A. So angle A is congruent to angle C. It says that D is the midpoint of AC. What do midpoints do? They cut things in half. So which pieces would have to be the same size then? I already have that angle A and angle C are the same size. D is the midpoint, so it's cutting this side in half. DB is congruent to itself because of reflexive property. D is cutting this side in half. So AD has to be congruent to DC. AD is congruent to DC. And why did we know that those two small pieces had to be congruent? Definition of midpoint. Almost done here. Do I have enough marked up on my picture to say that these two triangles have to be congruent to each other? Yes, using what? Using side, angle, side. If I call this first triangle ADB, how do I have to name the second triangle? CDB. What did they want me to prove in this problem? Angle ADB is congruent to angle CDB. What's the reason I can give for that? CPCTC. Those are corresponding parts. That's telling me that this angle up here is congruent to this angle right here because they are corresponding parts of congruent triangles. Homework 5 is due tomorrow. Please don't forget to bring that with you completed so that we can go over that. You guys will get your review for the test tomorrow as well. Have a fantastic rest of your day. Don't forget, test is on Thursday.